In the 1999 European Conference on Machine Learning and Principles and Practice of Knowledge Discovery in Databases, the following challenge was outlined. The bank wants to improve their services. For instance, the bank managers have only a vague idea of who is a good client, whom to offer additional services to, and who is a bad client, whom to watch carefully to minimize bank losses. Fortunately, the bank stores data about their clients, the accounts, the loans already granted, their credit cards issued. The bank managers hope to improve the understanding of customers and seek specific actions to improve services. The objective of the application is to find trends and patterns in which loans are paid back and in which leave the client in debt. We will analyze the loan and client datasets and create visualizations to predict whether a specific loan will be paid back or not. The data is made up of 8 datasets. District is a parent of account and client, account is a parent of loan, order, transaction, and display is a parent of card. The application classifies the data lakehouse, which provides data management features such as curation, correlation, normalization, analyzation, and modelization to help users. In Admin UI, set up the application by going to the Setup Application tab and filling out the file structure. When filling the entities out, make sure to indicate district, account, and display as a parent of the respective nested datasets. We will be taking advantage of Admin UI's bulk upload feature to create our meta and ingest models. Instead of manually filling out the column names and data types for each of the datasets, we have provided the specifications defined in the meta model for each of the entities. Starting with the district dataset, select the bulk upload meta option in the meta model dropdown in Admin UI. Import the district dataset's meta model CSV file into the bulk upload and press submit. After uploading the meta model, go to the bulk upload ingest model page. Like we did for the meta model, upload the ingest CSV file we have provided and submit the ingest model. After submitting, we can run the workloads under the batch management dropdown to go from STL to FTL and from FTL to PDL. We will repeat these steps with the rest of the datasets. Use the bulk upload feature for the entity's meta models and ingest models. Run the workloads from STL to FTL and FTL to PDL for each of the entities. Once you finish this for all the datasets, we can bring our data into Sprngy BI to create visualizations and models. In Sprngy BI, select the Add Datasets option from the Datasets page. Set the database to Apache Hive, set the loan application dataset from Schema, and select which table you would like to add. Note that Sprngy BI will only allow you to select one table at a time, but you can add as many tables as you want one by one. There are numerous visualizations you can create to map the correlation between a loan status, geographic location, average loan amount, and duration, salary, unemployment rate, and other statistics from the dataset. We will create a heat map to show the probability of a loan being paid off in a specific district. Select the loans dataset to open up the charts page. Set the visualization type to heat map, the x-axis to loan status, and the y-axis to the district. The metric category is a variable that the heat map plots the correlation of between the x and y elements. You can test out how the heat map changes based on different statistics. For the purpose of this demo, we will set the metric as the average loan amount. Run the chart query. You will be able to see how the probability of a loan being paid off in a specific district changes based on the amount of the loan. Paired with the other heat maps we can create for the different metric variables, this visualization tool gives banks a good overview of where a loan has the highest chance of being paid fully.